All right, so another example here where I'm going to need to use that G, F, and C form of the equation to get the equation of a circle. So I've got a circle, just skipping over this, contains the point -3, 4. So given that piece of information, I've seen that in other examples. Its center lies on the line x plus 2y equals 0. I've seen that before. What's new here is the circle is of a radius √10. So I'm given the radius here, which can kind of push me towards the HK method, but I don't have an obvious method of getting the center here. I've got, in kind of general terms, the center is -GF, and the line that's on, I have a radius, I have a point, but there's no kind of quick, obvious way to get the center, I would say, like getting, say, midpoint or something like that. So I would still say the GFC is the method to go with here. So I will form the equations as I have been in the other examples. So I'll go with the ones we've used already first. So circle contains the point -3, 4. So I will sub -3, 4 in here for x and y. So instead of x squared, it's going to be -3 squared, plus, instead of y squared, it's going to be 4 squared, plus 2gx is -3, plus 2f, y is 4, plus c equals 0. So just multiply that out. -3 squared is 9, plus 4 squared is 16. 2g times -3 is -6g. 2f times 4 is 8f, plus c equals 0. So I have got -6g plus 8f plus c. 9 and 16 is 25, and I'll just move that over to the right hand side, so equals -25, and there's equation 1. Equation 2 then I will get by subbing my center, in general terms, -g minus f into this equation here. Okay, so when you're dealing with the G, F, and C, the center is -g minus f. So take your x plus 2y, and you're going to sub -g minus f in for it. So -g plus 2 times -f is equal to 0. So -g minus 2f equals 0. There's equation 2. And then the third one, so the third piece of information I'm given is the circle has a radius of √10. So I am told that when I'm dealing with the kind of GFC form, then the radius is the square root of g squared plus f squared minus c. So this is going to give me my third equation with g, f, and c in it. So g squared plus f squared minus c is equal to the radius is √10. So what I would say there is square both sides. So get rid of it. You've got a square root symbol on both sides. Even if you didn't, you want to get these g, f, and c out from under this square root. So square both sides here. So you end up with g squared plus f squared minus c is equal to 10. And that's my third equation. So the reason here then that it says find the equations of the two possible circles that satisfy those conditions is, you can see here you've got a g squared and an f squared. So when you try and solve for g or f, you're going to end up with a quadratic. So you're going to end up needing to get two solutions for g, and that will give you two solutions for f, two solutions for c. So that's why it says find the equations of the two possible circles. And when it says equations of two possible circles, that's a definite prompt that you're going to need to use the G, F, and C method. Okay, and as I said, the reason is you're given the radius, and that ends up giving you an equation with g squared and f squared in it. So what I want to do is take equation 3 and rewrite it so that it just has F's or G's in it. So the method here is a little bit different to what I've done so far, just because I've got the squareds in it. All right, so what I'm going to do is take equation 2 and rewrite it so that I get G equals something, and then sub that in for G. All right, I would say, yeah, so I would say you've got a choice here. You can either rewrite this as G equals something or F equals something. I would go with G equals something because then you won't be dealing with fractions. If you try to rewrite this as F equals something, you have to divide across by 2. You'll end up introducing a fraction in when you don't necessarily need to. So first step, take equation 2, which is minus G minus 2F equals 0, and just bring the G over. So minus 2F is equal to G. And that's you done. That's what you need to do there. So now I'm going to sub minus 2F in there instead of G. I need to get rid of the C as well. So I want to kind of sub in just F's for C as well. So I'm going to go back to equation 1, which is minus 6G plus 8F plus C equals minus 25. So I want to write this as C equals and just have F's and numbers on the other side, okay? Because the idea here is I use this and I just rewrite this in terms of F, all right? So first step will be get rid of the G in this equation, and from equation 2, I know wherever I can see a G, I can sub in minus 2F. So this becomes minus 6 times minus 2F plus 8F plus C equals minus 25. Minus 6 times minus 2F is 12F plus 8F plus C is equal to minus 25. So C is equal to 12F plus 8F is 20F. If you bring it over, it's minus 20F minus 25. So there's your C in terms of F as well. So what you're going to do now is go to equation 3. Instead of G squared, you're going to have minus 2F squared plus F squared, that's fine, minus, and then instead of C, you're going to sub in minus 20F minus 25. All right, and that's equal to 10. So we're going to see already, this is going to give me a quadratic. That's going to give me my two solutions for F. So minus 2F squared is plus 4F squared plus F squared minus minus 20F is plus 20F minus minus 25 is plus 25 is equal to, and sorry, it was equal to 10 rather than equal to 0 here, so equal to 10. So let's get everything on one side and equal to 0 because it's going to be a quadratic. 4F squared plus F squared is 5F squared plus 20F. Bring the 10 over, becomes minus 10, so 25 minus 10 is 15. And that's equal to 0. So look, you could go and use minus b here straight away, and that'll spit out the answers for F for you. I'm going to do it by factorizing. So first thing I notice is 5 will divide into all of those. So I'm just going to divide across by 5 just to make the factorizing easier. So I'm going to get F squared plus 4F plus 3 equals 0. So F plus 1F plus 3 equals 0. So F is equal to minus 1, or F is equal to minus 3. All right. So there's my two answers. All right. So this is going to give us two possible values for G and two possible values for C. And we want to keep those together. Okay. And that's going to give us two possible equations of the circle. So what I'm going to do here is work out the G that goes with this. So G is equal to minus 2F. So G is equal to minus 2 times minus 1. So G is equal to 2. And I'll do the same here. So G is equal to minus 2 times F, so minus 2 times minus 3, so G is equal to 6. And then what's the C that goes with this one? Well, C is equal to minus 20, F is minus 1, minus 25, so C is equal to minus 20 times minus 1 is 20, 20 minus 25 is minus 5. Same thing then, just find the C that goes with this one over here. C is equal to minus 20 times minus 3, minus 25. So minus 20 times minus 3 is 60. 60 minus 25 is 35. So C is equal to 35. So there's a set of an F, G, and a C. Here's a set of an F, G, and a C. So just final thing we need to do here is I'm asked to find the equations of the two possible circles that satisfy these conditions. So sub your F, G, and C into this. All right. So let's just put my answers here. So my equation 1 is going to be x squared plus y squared plus 2g. So I'll go with this as being equation 1. G is 2 times x plus 2, f is minus 1 times y plus c, so minus 5 equals 0. So x squared plus y squared, 2 times 2 is 4, so plus 4x. 2 times minus 1, minus 2y, minus 5 equals 0. So there's the first equation. And then equation 2 is just going to be subbing these ones in. So equation 2 then, so x squared plus y squared plus 2, g this time is 6, times x plus 2, f is minus 3, times y, and c is 35, so plus 35 equals 0. So just tidy this up. So x squared plus y squared plus 12x minus 6y plus 35 equals 0. So there's the second possible circle. All right, so there's your equation 1. There's your equation 2. So again, I was asked for two possible circles that satisfy these conditions. That is very much a prompt towards using the G, F, and C if it says the two possible circles. The fact that I'm given 3 pieces of information, that's prompting me towards using the G, F, and C. It's going to give me my 3 equations. The fact that I can't, even though I'm given the radius here, that might make me think, oh, can I get the center here and can I use H and K? But there's no obvious way of getting the center from the other information I'm given. So it's G, F, and C, and that's my 2 equations then that I get.